Well, okay. So the first question here, it says, um, given a pair of give a pair of corresponding angles, alternate interior angles, I'm going to use colors too, alternate interior angles and alternate exterior angles using this image here. So you just have to choose a pair of corresponding angles to start with, like A wants corresponding angles. Of course, there are actually 4 sets of corresponding angles, and you only have to put down one. So the 4 sets of corresponding angles are shown up on the board here, and you just have to choose one of those sets. So I might choose, I'm going to try to keep the colors consistent. Corresponding angles would be like 1 and 3. If you already did this problem and you chose something else, that is fine as long as they are corresponding angles. And then alternate interior angles. So that would be alternate sides of the transversal on the interior of the parallel lines. So 2 and 7 would be good examples, but you could also do 6 and 3. You would get it correct. And then alternate exterior angles are alternate sides of the transversal on the exterior of the parallel lines. So like 5 and 4. Okay, then over here, we have a proof. There's going to be one proof on the test, and it's going to be this proof, of course, maybe with different numbers or a different angle pair, but you get the gist. So for this, you always put the given first. You'll just click send to proof, and it sends a given to the proof for you, which is nice. And just angle 4 is congruent to angle 8, and the reason is given. And when you click this button, it fills that in. Then you click validate, and it'll validate that reason. And then this proof is only 2 steps. It'll only be 2 steps on the test as well. You click send to proof for the second step, and it fills in this statement. A is parallel to B. And then you just have to choose a reason. It has a drop down with a bunch of different options, and you have to choose the right option. So the way to choose the right option is you look at the relationship between 4 and 8. Those two are corresponding angles. And we learned that if corresponding angles are congruent, then our lines are parallel. So that would prove that A is parallel to B. So if corresponding, and yes, this is an answer choice, if corresponding angles are congruent, then lines are parallel. So you just want to look for the relationship between the angles. It could be alternate interior, it could be alternate exterior. But yeah, if those angles are congruent, then the lines are parallel. The other way this could be asked is they could have the parallel line statement first and then the congruent angles. And in that case, you just say, okay, if lines are parallel, then corresponding angles are congruent. So just make sure to choose the one that's in the order of what you have. But if you practice it a few times, you should be good with that. Okay, then over here, it says, suppose that measure of angle 6 is 104 degrees. So I'll label that there. What's helpful too, because you're going to be doing it on a computer, sometimes it's helpful to like sketch it out on a piece of paper so you can label it. And then it says find the measure of angle 1 and angle 4 here. Well, alternate interior angles are equal, so if this is 104, this is 104 degrees. So we can plug that in and get half of that credit. And then this here, these two form a linear pair, so these would be supplementary to each other. So we can do 180 minus 104, and that comes out to 76 degrees. So measure of angle 1 is 76. You can also visually check to make sure it's correct too. Like if this is obtuse, all the ones that are obtuse would be equal to this. So if this is 104 and angle 4 looks like an obtuse angle, it would also be 104. Angle 1 looks like an acute angle, so it's not going to be equal to that. It'll be supplementary. So you can use the visual cues too to help. Okay, then down here, continuing. For this one, it has an image here, and then it has these statements to fill in down here. So it says measure of angle 2 is 125 degrees. We'll zoom out so we can see the statements at the same time. Okay, so here in the statement, so with the statements, I know it might look complicated, but really all you're doing is identifying angle pairs, which is what we've been doing the whole chapter. So we see that 2 and 3. So we have 2 and 3 right here. Those are corresponding angles. We see that 2 and 3 are corresponding angles, and we just write that in here. On the test, like there's a drop down and there's a few different options, and then you just choose the angle pair that you have. Corresponding angles, and since the lines G and H are parallel, which it said in the question here, corresponding angles are congruent. So that means that measure of angle 3 must be 125 degrees. Okay, then it says we see that angle 1 and 2. So 1 and 2 right here, those are vertical angles. So they are vertical angles. Vertical angles are congruent. So if this is 125, this is 125. 1 and 2 are congruent. So measure of angle 1 must be 125 degrees. And therefore, 1 and 3, the relationship between 1 and 3, they're alternate exterior angles. Alternate exterior angles. 1 and 3 are congruent. So the relationship between 1 and 3 is an example of the following rule. When parallel lines are cut by a transversal, alternate exterior angles are congruent. Alternate exterior angles are congruent. And you just choose that from the drop down. So not only will you see this in the practice test on Alex, but it's also like one of the weekly assignments. So if you notice on the practice test, there's one question that you're messing up like often, I would go and do the weekly assignment too, so they'll give you 4 or 5 of the same problem to get really good at it. And then for this one, find the values of x and y. So looking at this, I have vertical angles, which I know are equal, but I can't set this equal yet because I can't solve for both x and y at the same time. So looking at what else I have, consecutive interior angles are supplementary. So this plus this would equal 180. So like x plus 63 equals 180, and I can solve for x. So subtract 63, x equals 117 degrees. And then put that in the box right away, so that way at least you get half credit, you don't forget. You could set up an equation like this, or you could know to do like 180 minus 63 to get 117, kind of whatever is best for you. Okay, and then once you have x, it makes it easy to find y, because vertical angles are equal, so we can do 117 equals 5y plus 7, and we can solve for y. Subtract 7, 110 equals 5y, divide by 5, and y equals 22. Once you have that done, you can flip to the back. Okay, on the back, first one, super easy problem, which is nice. I've also seen these on like the PSAT and SAT, just like a very simple problem that everyone can get right if they know what they're looking for. So here it says write an equation in slope-intercept form. So slope-intercept form is y equals mx plus b, m being slope, b being y-intercept. It says with a y-intercept of 2, so that means b equals 2, and a slope of this, so m equals negative 4 over 3. So all we have to do is plug this into the equation and we'll get our answer. Y equals negative 4/3 x plus 2. and you can use like the fraction symbols and all that to get this right. You could have the negative symbol on 4, because negative divided by positive is negative, or you could have the negative in front of the fraction. Either way, it's correct. Let me zoom in a little bit so it's easier to see. Okay, then the next question. This one, we made sure to include it because it's very popular on PSATs and SATs. It says a line passes through this point and has a slope of 6. M equals 6. And then this here, the coordinates are x and y. Write an equation in slope-intercept form, so y equals mx plus b for this line. Okay, so y equals mx plus b, y equals the slope of 6x plus b. We need to find the y-intercept. They didn't give it to us. So the way that we're going to do that is take our coordinates here and plug them into this equation. So our x-coordinate will get plugged in, it's distracted like arrow, get plugged in there. And then our y-coordinate will get plugged in here. So we get -5 equals 6 times 2 plus b. And then we can solve for our y-intercept and then plug it into this equation here. So you get -5 equals 12 plus b. To get b by itself, subtract 12 from both sides. -17 equals b. So that's our y-intercept. And we can take that number and plug it in here. Yeah, so we're taking that and plugging it in there. Y equals 6x minus 17. Okay, then down here, this one is pretty simple and straightforward. Consider the line y equals 1/3 x. So this would be the slope of the line, 1/3. What is the slope of a line parallel to this line and a slope of a line perpendicular to this line? Parallel would be have the same slope, and then perpendicular, the slope would be opposite, reciprocal. So like 1/3 and -3/1, like opposite sign and then flip the fraction. Okay, so for a slope of a line parallel, it'd just be the same, 1/3. And then slope of a perpendicular line to this would be -3/1. Or you could put it in the box as -3. Alex will accept both as correct, so however you want to put it in. Okay, then continuing with that concept for the next one, it says, suppose we're given the following coordinates right here. Find the slope of each line and then determine whether they're parallel, perpendicular, or neither. So once we find the slope, we can compare them. Remember, parallel lines have the same slope, and then perpendicular lines opposite, reciprocal. So to find the slope, we need to use the slope equation, which is y2 minus y1 over x2 minus x1. That's on the reference sheet. So you don't necessarily need to memorize it, but we use it so much that you probably will. Okay, so first set of coordinates, x1, y1, x2, y2, and then off to the side over here, we're going to do the slope formula. So y2 minus y1 over x2 minus x1. -6 over +3. So like add the opposite, and we get -2. So -2 is the line 1 slope. Okay, then line 2, we're going to do the same thing. y2 minus y1, 3 minus -5 over x2 minus x1. The opposite, we get 8 over -4, which is -2. So that is line 2 slope. Okay, and then line 3, same thing. Once you get the hang of it, it goes pretty fast. Like, it doesn't take too much time. y2 minus y1, 8 minus 0. Wait. 8 minus 0 over 1 minus -3. 8 over the opposite, 4. This equals +2. So line 3, the slope is +2. Okay, then once you have the slopes, you plug them into the box. So line 1 has a slope of -2, line 2 has a slope of -2, and line 3 has a slope of +2. And then for each pair of lines, determine whether they are parallel, perpendicular, or neither. So parallel has the same slope, so 1 and 2 would be parallel. 1 and 3, not the same slope. If it was perpendicular, it would be like -2 over 1 and +1/2. And we don't have that situation. So 1 and 3 are neither. It's not the same slope and it's not opposite reciprocal. And then 2 and 3, not equal and also not opposite reciprocal, so it's neither there as well. Okay, and the bottom one here. Okay, the bottom one here, continuing with the same concept. It's good that we have a few examples because these are highly tested on various different tests. Equations of 3 lines are given below. Determine whether they're parallel, perpendicular, or neither. So we need to look at the slope and then determine whether they are the same slope, which would be parallel, or opposite reciprocals. So 1 and 3, I can pull the slope out right away. I can see that 1 and 3 have the same slope over 3, so 1 and 3 are parallel. I can choose that. 1 and 2, I can't tell because this isn't in slope-intercept form, so I can't just like look at the slope. So I'll just do this off to the side and rearrange it to get it into slope-intercept form. I rearrange it, I need to solve it for y, so that way it's in y equals mx plus b format. So subtract 6x, -2y equals -6x minus 2. Divide by -2 to get y by itself. And y equals -6 divided by -2 is +3, and then this would be +1. So our slope here is actually 3 as well. So that means that 1 and 2 are also parallel, and then 2 and 3 are also parallel because they all have the same slope. If these equations, I don't believe this happens on the test, but if these equations came out to the exact same equation, then it wouldn't be parallel or perpendicular, it would be the same line. So if you like solve this out and it was the exact same equation as this, for example, like it was y equals 3x minus 3, it would be the same line, which it doesn't happen on this test, but it could happen on like testing or something. Okay, then one last question. This one right here. Write equations for horizontal and vertical lines passing through points 4, 5. So for this, I would use the HOI and VUX acronym. HOI is for horizontal, 0, slope, and then y equals. So horizontal is y equals 5. This would be our y, right? And then for vertical, V vertical, just kind of undefined slope, and then x equals. So here is our x. X equals 4. So the acronym will definitely work. If for whatever reason you forget the acronyms, you could always just graph it and figure it out. So 4, 5, 1, 2, 3, 4, up 1, 2, 3, 4, 5. Here would be your point right here. A horizontal line through that point would be at y equals 5. And then a vertical line through that point would be at x equals 4. So yeah, you could always graph it if you forgot the acronyms. Okay, that's all. So we still have 23 minutes left in class, which is a good amount of time. I want you to leave out this practice test on your desk for me to go around and grade it and complete the Ch.3B practice test on Alex. So these are samples of all the questions that will be there. So use this as a guide to help you as well. Okay. Go ahead and Peter and then